Hello YouTubers and fellow hams. Well, I want to do another walkthrough for Linux and Satdump. Now Satdump is a great Swiss Army knife for satellite reception, decoding, and recording. It lets you track, control an antenna rotor, receive with your SDR receiver, record the baseband, or demodulate and decode the information coming from the satellite, like weather images from weather satellites, for example. It has a scheduler. It downloads the TLEs directly from the network, from NORAD, and will let you schedule and automate recording and capturing stuff from satellites. It's a great program. And of course, fully open source, cross-platform. You can install it on Mac, Windows, and of course, Linux. Most of the Linux repositories will have it in there. You could simply install it with Synaptic or an apt-get or an apt-install command, but that's going to be an older version. And this program is in rapid development. It's being updated pretty regularly. So if you want to get the most current version, really the only way to do it is to build it from source. And a lot of people go, oh, yeah. They have great instructions. They have step-by-step, simple, just a few command lines that we have to copy and paste into a terminal, and it just works. And so I'm going to walk you through downloading and building the current version of Satdump from source on Linux. And it's really easy. It's not hard. So let's go ahead and get started. So here we are on the computer. This is the satdump.org homepage, where they tell you about the program, show you what it looks like and what it can do. And basically it is attempting to be an all-in-one solution for capturing satellites. It will use your SDR directly. I'm going to be using it with an SDRplay. And if you have an SDRplay and you haven't set it up under Linux, that's really easy. I have a separate video on that, which I will link in the description below. The current version is 1.2.2. They're still working on 2.0, but the version you get with your package manager is probably going to be older. So we're going to look at how you build this from source, which scares a lot of people off, but it's actually not too difficult. They have excellent instructions. And to do that, we're going to go over to their GitHub page, which again, I'll have these links in the video description. But you go to their GitHub page, and under the code tab here, if we scroll down, we get to the README, which has information again, but if we keep going down, we'll get to build instructions. Here we go, building and installing. And we're going to be looking at the Linux installations. Now, the first thing we need to do is install dependencies. These are the utilities you'll need to build the software, various libraries and things that it depends upon. And they have this broken down here for different OSs. I'm going to be looking at the Debian based one, which is Ubuntu, Mint, Pop! OS, many of those. If you're running Red Hat, you've got instructions there, Alpine, Gentoo, OpenSUSE. But we're going to be looking at Debian. So I'm going to hit the little arrow there to expand that. And they give you individual install lines here for the various dependencies, but they also have a one-liner. This will install all of the dependencies in one go. So that's the one I'm going to copy. And in following these instructions, they have some exceptions here. If one of the particular dependencies is not available, you'll have to build it separately. Most of you will probably not have to do this. I think most of the modern Debian builds are going to have this available. But then you just get these instructions here. Oh, and then they also have Raspberry Pi information too. Android. Interesting. And they've got a Docker. That's getting a little more advanced. We're going to look at building it from source. So the first thing we need to do is install the dependencies. So I'm going to come up here and I'm just going to copy this one-liner. Oops. Didn't need to go all the way over there. There we go. I'll highlight it. I'll right-click and I'll select Copy. I'm going to type Control-Alt-T to open a terminal. And we will just paste that line into the terminal. Shift-Control-V to paste it, or you can come up here to the Edit menu and select Paste. And that pastes our line in there. When I hit enter, it's going to ask me for my password because the first thing we see here is sudo, super user do, means run this command as the root user. So when I hit enter, it'll ask for my password. And then it should go through and install the dependencies. It's telling me that I have some of these already installed. It's telling me down here what it's going to install. And has some suggestions. Alright, so we're just going to go ahead and let it install 31 packages. And we're off and running. Once this finishes, I'll come back and we will go through the build instructions. Alright, we're done with the dependency install. No issues there. It took a couple of minutes. Let's go back here and look at the next step. Building Satdump. This is where we're at. The first thing we're going to do is pull down the repository. This is going to, git clone is going to pull down the source code and all of the extra information that's needed. So we need to be in a directory where we're going to do our build. It doesn't tell you that here, but we're going to go ahead and change into my downloads directory. We'll do it in that folder. So right now, if I do a pwd, print working directory, we can see that I am in my home directory. I'm going to cd space downloads with a capital D. Now you can see I'm in my downloads directory. And now I'm going to copy this git command. And we'll come back here and do a Shift Control V, enter. And it will start cloning the Satdump. Now this is going to take a little while. There's a lot of data for it to pull down. Again, I'm going to pause the video and I'll come back when it has finished. Alrighty, so the clone has finished. It took about 5 minutes. Let's go back to the web page. And what's our next step? We're going to cd into the created Satdump directory. I'll just copy that. And again, we'll just Shift Control V. There we go. And the next line is it's going to make a build directory and change into that directory. Okay, no errors. If you do not want to build the GUI version, well, we do. If you want to disable some SDRs, you can add minus plugin. Well, let's go ahead and include all of the. I don't know why you wouldn't want to include all of the support. Maybe you have several SDRs you want to use. Okay, this is the first make step. This is going to start. This is going to configure the build based on your system. So I'm going to highlight that and make sure you get those last little 2 dots there. Copy. And CMake is going to look at our system and build a configuration file for the actual compiling. Enter. This should go pretty quick and hopefully we get no errors. We shouldn't because their dependency install took care of installing everything we'll need. And again, no issues. That's good. This is pretty easy, isn't it? Now this is the make statement. This is actually going to do the compile. Now you see where this says the little tilde or little mark and nproc mark. That means we're going to put in the number of processors that we have in our system. We're not going to actually put that string in there. It's going to be make minus j and a number. So I'm going to copy that, but back here in the terminal, the way to determine how many processors you have is a command called lscpu. And that lists our processor information. And up at the top here of the data, CPUs 8. I have 8 processor cores or 8 threads available. By putting that in there, it's going to spread the build across all of your available processor cores and make it go a lot faster. So if I've got 8, that's the number I want to use. So I'll come down here, Shift Control V, so there's our make minus j, and I'm going to put an 8 to tell it we have 8 processor cores. Now this is going to take a while. I'll start the build and off it goes. It's now compiling the program. You'll see several messages pop up. It should not give you any errors. It should eventually just finish. And again, this is going to take a little while. Oh, there goes my CPU fan, because we are using all of my available processing power. Okay, so again, I'm going to let it finish, and I will come back to you when it has completed. It has finished building. No issues, no errors. Excellent. Not too hard, is it? All right. Now, the next thing we have here is they give you an option of how to run it without installing it. You could just leave it sitting in that folder in your downloads directory and do this every time you want to run it. But we're going to go ahead and install it, which is right here. To install system-wide, simple, sudo, make, install, all lowercase. So, sudo, make, install. Wants my password. It has copied everything into place. We should now be able to run the program from our system menu. So if I bring up my menu, type Satdump. There it is, right at the top. Let me plug in my SDR, my RSPDX. There we go. And I'll go ahead and run the program. It saw my SDRplay. Let's expand this to full screen. And here we are. Offline processing would let you process files that were already recorded. We're going to go to the we're going to go to the Settings tab first here. Settings. Now there's a lot of stuff under here. You might want to walk through it and just maybe look through their manual online and walk through this. The important stuff, I think, is going to be file input output here. This is where you set directories that you're going to use for recording and saving information. I've already set these, but the baseband recorder directory is where it's going to record the full information that it captures from the satellite, the full RF information. That's a really huge file. You would use that if you had specialized processing software that you needed to use on data that you pull down from the satellite. Probably what most of you are going to do is you're just going to be like receiving meteor satellites and weather information and various things like that. And the live processing directory is where that data goes. The rest are pretty much self-explanatory. So you'll set your file paths here, and you just use the open button over here to browse to the location you want to use for these various inputs and outputs. Let's go to the Recorder tab. This is where all the action happens. Up here at the top, this is your SDR information, and you can see that it recognized my RSPDX. It's already got that selected, and I could just run the receiver here directly. I could put in a frequency, various settings for your receiver. On the SDRplays, these gains here, you want to bring these all the way up. I've just found that it's just not very sensitive otherwise, but you can fiddle with that depending upon your your local noise source. That's just regular receiver settings. If I hit start, nothing. There it goes. It'll start the receiver running. But we'll go ahead and hit stop. I want to show you automation. FFT, that's the waterfall settings here, the colors and sensitivity. Processing is where it would be processing, where you could pick a pipeline. Satdump has several different processing pipelines in here for different satellite types. Analog demodulation is just receiving the regular audio transmission from the satellite, and you can set like the modulation type here to whatever you're needing to receive, the nominal frequency of the satellite, and so on. That would be handy for like slow scan TV transmissions from the ISS and so on. So the processing tab is what it says, processing pipelines. Recording. again, just starts recording. If I had the receiver running and I was receiving a satellite manually and I wanted to record it, I could hit start, and that would record the baseband, the full information. Tracking. This is where it gets interesting. Automation is under here. This is what I want to show you. So, tracking will show you live whatever satellite you are currently receiving and on this azimuthal plot here. But if we come down here to schedule and config, this is where you can do automation. I'm going to bring that up. I've already got some entries in here for the Meteor Russian weather satellites and this Russian CubeSat that I've been trying to receive slow scan from. But let's say we wanted to add the ISS. I'd come up here to search all satellites and type in ISS, and there we go, and pick the module that we want to track, like Zarya. So they're both going to give you the same information. They are connected to each other after all. And I hit this little arrow to put it over into my active tracking satellites. We come down here to ISS Zarya, and then we enter the information that we want to automatically capture. So if I wanted to capture their voice repeater, I would set the frequency, which is 437.8 megahertz. And I would check what I want it to do. I want to do record is recording the baseband. Live is running one of those processing pipelines. So I'm going to check live. I'm going to pick analog demodulation because I want to receive the FM transmission. And I'll hit config. And this is receiver settings. So our frequency is wrong here, 437.8 megahertz. And it is FM. Filter bandwidth, yeah, it's narrow FM, so that's fine. So we set all of our information here for our recording. Doppler correction, we want that on. That will correct the frequency for Doppler shift, and I'll hit save. So I've configured ISS live analog demodulation. You can turn your different satellites on and off by checking these boxes here. Let's say I wanted to also capture the Russian weather satellites. I'm going to hit the check mark on live for those, and I have chosen the Meteor M2-X LRPT pipeline. That's the decoding of the weather satellite images. And you've got some configuration options under there that are just minimal stuff, but we're fine. So I now have 3 satellites that I'm going to have it automatically capture for me. I've got display local time set here. You can, if you uncheck that, it'll show UTC time. You'll see where that shows up here in a moment. And stop SDR when idle. You probably want to check that. That's going to turn off the receiver when it's not actively recording a satellite. There is also rotator configuration in here if you have set up some kind of remote rotator controls, which I'm not going to get into that because I don't have one. You could have it like with a Yagi on a rotator, you could have it track the satellite physically with the antenna. But we've got scheduling set up. I'm going to engage auto track. And now you can see it's showing us that coming up at, let me see, 4:56 a.m. It's now 4:29, so that's a little while from now. But I'll record that pass to show you what it does. The Meteor M2-4 weather satellite, Russian weather satellite, is coming up. Its maximum elevation is going to be 17.9 degrees, not great. We might get something out of that. And I'm not going to have another capture until Meteor M2-3 at 8:16 a.m. And again, that's a very low elevation. So I don't have any really good passes coming up. ISS, mid-morning. But I'll be able to record this Meteor pass to show you how it decodes the Russian weather satellite. So I have this now set up to automatically capture that. I've engaged auto track. I can close the scheduler window. And you'll now see that our tracking tab here shows that Meteor M2-4 is our next satellite. AOS, which means acquisition of signal, in 25 minutes and 54 seconds, 53, 52, and counting down. When we get to the satellite pass, this will automatically turn on the SDR. You'll see it in the waterfall, and it will show you the decoding process going on. And then once it's done, we can look at the weather satellite information. So again, I'm going to go ahead and pause the video, and I'll start recording when we're down to about 30 seconds from the pass beginning. It's about to start. 2 seconds, 1 second, and there we go. It turns on the receiver. It sets the frequency. This is the demodulator that's going to demodulate the satellite if we can pick it up. Now right now its elevation is only 0.6, 0.7, almost 1 degree off the horizon, so we're probably not going to see a signal until that gets to about 5 or 6 degrees off the horizon. But it is now automatically going to demodulate and decode the images that we receive off the Meteor satellite. So we'll watch over here, 137.9. We should start to see the signal in that area, and when it's locked into it, the demodulator should show, since it's a quad PSK, we'll see 4 different areas of signal over here, and it'll give us updates here as to how good it's synced up and locked in. Now we're just starting to see it. If you look in the waterfall here, you can just start to see that band of modulation just beginning to appear. See the lighter color? 3.7, 3.8 degrees elevation. When that gets to about 5 degrees, we should start to get a decent signal and maybe lock into it. This is not a great pass. It's just going to skim the horizon from the north down to the southwest. While that is still rising, let's hop over. I'm not going to go through too much on Satdump here. I'm just going to show you this basic operation, but they have a really good documentation. Docs.satdump.org up there, and you can see that they have details on all the different satellites, information about them, plugins, satellite support, SDR options, information for different SDRs, and then a breakdown of each of the functions of the program: satellite tracker, composite system, projection system, etc., etc. A frequently asked questions and troubleshooting section. Very, very good documentation at docs.satdump.org. So now that I've got you installed and the program is running, go there to really learn how to use it. Okay, let's go back and see if we're starting to, yeah, we're synced now. You can just sort of see it. We're not getting a great signal. Like I said, it's not a great pass, but you can see that it is synced. The deframer is synced, which means it is capturing data. You can kind of sort of see the quad over here in this demodulator window over here. You can kind of sort of see the quad concentrations of the signal. When we get a really good signal, these will be very well defined for little clusters. Yeah, you can see it's sort of dropping sync here. It's not a great signal on this pass. But when this pass finishes, down at the bottom of the window here in the status, it tells you what it's doing under the info. After this pass finishes, you'll see it go through the process here of demodulating and decoding the data in this pipeline. There you can see we're getting more defined. The more defined these 4 dots, these 4 clusters of dots are, the better the signal. Alright, I'm going to fast forward to the end of the pass, and we'll be able to watch it decode and take a look at what we captured. It is just about done. We lost the satellite signal about a minute ago. Elevation is down to 1.4 degrees. Loss of signal, LOS, in 27 seconds. So I've got to wait for it to actually reach that LOS. Even though we've lost the signal on the satellite, it just keeps on going until the satellite actually eclipses or goes down below the horizon. 14:13. Now, when this finishes, watch this info bar at the bottom of the screen here. You'll see the process as it goes through and decodes the data that it captured. And then we'll go look at what we captured. There it goes. saving the different images, drawing map overlay, saving out those images. So it's processing all the data, and when it finishes, we'll go take a look at it. It saves several versions of the images, with and without maps, false color, infrared, whatever's available. Okay, done. Let's go take a look at what we got. And this is the directory that I set in there for it to record the live stuff. Here we are. It shows the date and time, that's the name of the folder, and the satellite and the frequency. If we open that up, this is all the data that it pulled down, telemetry data and so on, but this is what we're interested in here, MSUMR. And here are all the images. Let's see what we got. Well, it was not a very good pass. We had a huge chunk of missing data here. And it's nighttime. This, I think, is one of the infrared images because we can see the clouds. I want to see if I can find the one with the map overlay. False color with the map overlay. Another false color image. Yeah, not a very good example, like I say. It's nighttime. This would have been our color image here. We can just sort of see a bit of the coastline. Usually this will be filled in pretty good, but that was a really poor pass. Now that image and that pass was not very good, but here's an image from another pass that I recorded that was much better, and you can see the quality of it. This is zoomed in. It's actually a very high resolution image. This is zoomed in quite a bit, and it's still at HD. Let's go back here to our schedule and config, and let's go to config on one of these Meteor pipelines. I think, I gotta disable auto track. There we go. Now I can configure it. Yeah, I should have checked this box. Fill missing data. In the case of the Meteor satellites where you get just individual little dark lines, it will attempt to fill that with whatever it could from the data set, and we'll try to make a more complete image. You want to check that. It just makes for a better image. In this case, it wouldn't have helped us much because we just have a huge amount of missing data here where we just did not have a signal from the satellite. But these little lines would have been filled in, and it makes a much cleaner image. So that is Satdump in a nutshell. That's installing it from source, getting the most current version, and some basics on how to set it up and capture some data. There you go. Pretty easy. Step by step, right there on their site. Copy, paste the commands in. Shouldn't have any issues if you're on a current or modern version of Linux. As of the recording of this video, the end of 2025, I was on Ubuntu 24.10, which would be the same as Debian 12. So anything from that version on should have no problem at all. In fact, I think you could go back a version and it would still work too. So I hope you found that useful, and we'll see you in the next video. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.